continued. Now here we have the vertically moving position of the horses, where my P5 is when the horse moves 1 unit right and 2 units up. So the horse moves 1 unit right and 2 units up, and then I get this to be the coordinates 1, 2. Similarly, my next coordinate is when the horse moves 1 unit right and 2 units down. So I have my coordinates which are given by 1 unit right and 2 units down, and hence -2. Next, I have my P7, which is when the horse moves 1 unit right, 1 unit left, and 2 units up. So here I have my coordinates which refer to 1 unit left, and hence -1, and 2 units up, so +2. Similarly, the last case being that the horse can move with 1 unit left and 2 units down, and therefore it moves both the ways -1 and -2. Moving to the left, -1, moving down, it's -2. So these are the 4 possible coordinates which I identify through the horse moving in all of its directions. So totally I have 8 coordinates which the horse can make with the possible positions on the chessboard. Is how we connect the coordinates with real life system. The possible coordinates are 8 coordinates which the horse makes with the Cartesian form. The first being 1 unit, this thing, and then 1 unit, the first position being 2 units right and 1 unit this, and this being P2, and this being P3, and this being P4, and then P5, P6, P7, and P8 is the different types of positions which are made by the Cartesian system. Is how we understand the connection of the movement of horse with chessboard. There are 8 different positions made by the horse in the chessboard when we locate through the Cartesian plane in XY coordinate system. Now let's see how we can plot the points on the coordinate system accurately using the graph scale. What is the scale? Before we try to understand the Cartesian plane and locating the points in the Cartesian plane, the scale is the base which gives us approximation in locating the points. Let's see in brief about the scale used in plotting the points. Let's see what a scale is. Imagine I take an x-axis and a y-axis with origin, with xx dash being the x-axis and yy dash being the y-axis. Now scale is the measurement used when we move the points along x and y axis. For example, when I move with a scale, when I locate with points 1, 2, 3, 4, etc., I mean that I have measured this to be 1 unit, and on the graph paper, the grid lines are generally at a distance of 1 centimeter each, and that grids are taken as the base of the scale. That is, for every grid which is generally denoted by the scale for x-axis is 1 centimeter equals 1 unit if this is taken to be 1 unit each, and y-axis, if I take 1 centimeter to be 1 unit, then in this case I refer to this distance of 1 centimeter on the graph sheet grids to be 1 unit what I identify. Similarly, on the left side, I take every 1 centimeter of the grid on graph paper as 1 unit. So every unit refers to this. Because I also refer my y-axis with 1 centimeter equals 1 unit, I have this to be 1, 2, 3, 4 and 5, and this would be -1, -2, -3, -4 and so on and so forth. So I have each of the coordinates plotted on the scale of x and y axis. Is how we plot the scale. Scale is very essential when we plot on the graph sheet because scale gives the accurate measurement of the point from its initial position 0. Let's see another example through which we can understand the scale more better. Now that we have discussed about scale in the previous session, let's try to take another example problem to understand the concept more better on scale used in plotting the points. For example, I have an example problem which says plot the point (1, 2) using the scale (1 centimeter equals 1 unit on y-axis and 1 centimeter equals 0.5 unit on x-axis. Now let's try to understand the scaling concept better using this example problem. The example problem reads clearly, plot the point 1, 2 using the scale. That means the scale is clearly referred out here with suitable distance fixed. Now the scale in this problem says 1 centimeter is 1 unit which we need to take on y-axis, and every 1 centimeter of the grid in the graph sheet should be measured with 0.5 units on x-axis. So let's see how we understand the scale concept practically on the graph sheet. Now that I have the point, let me just take the xy coordinate system x dash, y dash. Now here my point refers to 1 centimeter is 1 unit on y-axis. Initially I start with x-axis, which says that every 1 centimeter of the grid on the graph sheet must be taken as 0.5 units. So here I have my origin and these are the grids separated on the graph sheet. Now these 1 centimeter grids separated on the graph sheet are referred to be taken as 0.5 units on x-axis, as clearly referred in the problem. Therefore, I do not take this as 1, but I take this to be 0.5 units. Indirectly, the 1 centimeter measurement on the graph sheet by this grid refers to 0.5 units actually by the scale, is how we understand the scaling concept. Similarly, the distance from here to here must be 0.5. Therefore, the next value would be 1, because 1 minus 0.5 would give me 0.5, or 0.5 is added further. You can also refer this as 0.5 added to this refers to 1. So when I want to find the next coordinate, it is about adding 0.5 to the previous value of 1, which gives me 1.5. The next is adding 0.5 to the previous, which is 1.5, which gives me 2. And then on the left, minus 0.5 minus 1, minus 1.5 and minus 2, etc. This is how the scaling is done on x-axis according to the given question. Next comes the scaling on y-axis. How do we scale on y-axis? Clearly on y-axis, the measurement refers 1 centimeter to be taken as 1 unit. So every 1 centimeter of the grid is taken to be 1 unit. So I get this to be 1, 2, 3, 4, 5. And every unit down is referred as minus 1, minus 2, minus 3, minus 4, etc. is how we get the different grids out here. So scaling on x-axis is done with 1 centimeter equals 0.5 units, and scaling on y-axis is done with 1 centimeter equal to 1 unit. And then comes the locating of the point on the Cartesian plane, this Cartesian plane. So let's see how we can locate the point on this respective scaled coordinate plane. Clearly I see the point here. Let me denote with 1, 2. Now here this refers to the x coordinate being 2, 1 and my y coordinate being 2. So let's see how I can locate with x equals 1 and y equal to 2. So as I see the x coordinates moving horizontally along the right and left, and the y coordinates moving vertically up and down, so clearly the x coordinate moves 1 unit to the right. This being positive, it moves 1 unit right, and then it moves 2 units up. So I get the point to be here, which is 1 unit and 2 units to this, and therefore I get the point P, which is exactly out here. So this is my point 1, 2, depending on the scale as given respectively for x and y axis. So my point is 1, 2 is how we get it. It's easy. Plotting the point is based on scaling the plotting and then locating the point respectively through that scale. Now that we have discussed about scaling concept, the rules of scaling the x and y axis, let's see now how we can locate the points and how are the steps and procedures involved in locating the points in the Cartesian plane, respectively through the given scales. So let's take an example problem to understand the concept. Plotting the points is the session for today. So let's see about plotting the points. So for example, I have a question which says, plot the points P is plus or minus 1 and plus or minus 2, and Q is plus or minus 2 and plus or minus 1 on the Cartesian plane. So I would like to plot the points P and Q in the Cartesian plane, provided that the given condition is with a scale 1 centimeter equals 0.5 units on each of the axis. On each of the axis is what is the given question. So let's see how we can do this problem through the scaling concept and locating the points exactly on the graph sheet. Now that it's given clearly with the scale that 1 centimeter is 0.5 units on both x and y axis, we take the centimeter of 1 centimeter of the grid to be subdivided with each of the unit being 0.5 unit difference. So let's see how we can make the scale before we locate the points P and Q. Considering the Cartesian plane x, x dash and y, y dash, let's try to make the 1 centimeter grids. The first thing we identify in doing this type of problems is locating the grids. So I just mark the grids, each of them, and then here each of them is 1 centimeter, and then here. Now that on x-axis, on each of the axes, in the sense both on x and y-axis, the scale is the same, is what the question refers. So on x-axis, starting initially with x-axis, my 1 centimeter is 0.5 units, and therefore this moves each of 0.5, 1, 1.5, 2, 2.5, etc. as in the previous problem. Similarly, on the left, it moves minus 0.5, minus 1, minus 1.5, minus 2, and etc. with minus 2.5. Similarly, on y-axis, it is 0.5, 1, (1.5) and 2, minus 0.5, minus 1, minus 1.5, and minus 2 is how I divide the scale with 1 centimeter equal to 0.5 units. Next, it's now about plotting the points on this scale for P and Q. As I observe, there are different values for P and Q, so in this case, plotting the points is very easy if you can convert the given points into the tabular form. So let's see how we can do the plotting concept through the tabular form. As seen here, I clearly see that there are P and Q points out here, which I take it in the form of the table. I make a table of x and y values where this is x and this is y. Now let me pick all the x values of both the points P and Q. So I have first x equals plus 1 and then x equals minus 1 is what we get. And again I have for P, these are the coordinates for P, and then I have x equals to 1 and x equal to minus 1 for the coordinates of Q. So each of the coordinates have x as plus or minus 1 and plus or minus 2 is what we get. Then I have my P equals 1 implies P equals 2. And P equals minus 1, x equals minus 1 implies y equals minus 2 is how I understand this problem. Therefore, 2, 1 and minus 2 minus 1 is what we get as the coordinates plotted on x-axis. I take the plus or minus respectively for plus and minus. And therefore, I get 4 different coordinates for each of P and Q. So I get the point 1, which is 1, 2, then minus 1, minus 2, then 2, minus 2, and minus 2, minus 1. So on the whole, I have 4 coordinates which I'm going to locate on the coordinate system. First, coming with this, I have this to be 1, 2. So 1, 2 is my first coordinate. So in this particular problem with this tabular form, we're going to plot the points each of 1, 2. Initially, my first point is 1, 2, where x is 1 and this, which is 2. And then coming to the second point, I have my x, which is minus 1, and y, which is minus 2, which comes out here. Similarly, my third point, which is 2 minus 2, is 2 and minus 2, which comes out here. 2 units right and minus 2 down. And my fourth point, which is minus 2 minus 1, moves minus 2 left and minus 1 down, is how I locate the 4 points. This being 1, 2, this being minus 1, minus 2, and this point being minus 2, minus 1, and this point being 2, minus 2. One, 2, minus 1, minus 2, 2, 1. This is 2, 1 and 2, minus 2, minus 1. So my third coordinate, which is 2, 1, is out here, but not 2, minus 2. So I have the coordinates minus 2, minus 1, minus 1, minus 2, 1, 2, and 2, 1. The 4 coordinates denoted by P and Q, represented or plotted on this Cartesian plane using the scale 1 centimeter equals 0.5 units and 1 centimeter equals 0.5 units on both x and y axis. Plotting the points is done through the construction of the table with the first row with all x values of the given points and the second row with all the y values of the given points, and then plotted accordingly through the pairs. The first pair gives the first point, the second pair gives the second point, the third pair gives the third point, and then the fourth pair, which gives me the fourth point on the Cartesian plane, is how we understand the construction of or the plotting of the points on the Cartesian plane using the concept of the scaling process, scaling and plotting the points on the Cartesian plane. Now that we have discussed about the Cartesian plane and the plotting of the points on the Cartesian plane with its respective definitions, let's now define or discuss about how we can just identify the points on the Cartesian plane, or how we can identify the coordinates of the points in the Cartesian plane if the point is given in the Cartesian plane. It's just like the reverse process of what we have learned in the previous sessions. Given the point in the Cartesian plane, what are its coordinates is what we are going to investigate in the session. Let's see, for example, start with the heading. Reverse process given the point in Cartesian plane implies, how do we identify its coordinates is what is called the reverse process, because in all the sessions we have discussed about a point which is plotted on the Cartesian plane. But what if the point is given in the Cartesian plane and we would like to locate the point with its coordinates? The values of its abscissa and ordinate is what we need to discuss in the session. reverse process is equally important as the forward process of learning to make the learning more stronger. So let's see how we can understand the concept more stronger and more deeper using this reverse process of understanding. For example, I have a question which says find P in the plane. Say for example, I have the given plane which is x-axis, y-axis. This is etc. And on the left, I have minus 0.5, minus 1, and minus 2, etc. And then I have this to be and here I have clearly that this is the x-axis and this is the y-axis, and the scale on x-axis is 1 centimeter equals 0.5 units, and the scale on y-axis is every 1 centimeter grid is 2 centimeters, is 2 units. So I have the scale for this problem, which is on x-axis 1 centimeter is 0.5 units, and on y-axis 1 centimeter is 2 units. Is how we understand the scale on x-axis and y-axis. So coming to the problem, if I have a point, say located out here, and I have another point, say it's out here. Let's see how we can locate these points P and Q using the reverse process of understanding the concept. Now that the point is given without its coordinates, the challenge is to find the x and y coordinates, that is indirectly to find how many units the given point is moving from its initial position, either right or left or up or down, is how we understand the concept of identifying the point. So let's see how we can do that. Here is point P, which clearly is understood to start from initial position moving 1, 2, 3. So it moves 1.5 units to the right as given by the scale of 1 centimeter 0.5 units. So it moves 1.5 units to the right, and then this point moves from here back 1, 2, 3. So I understand that the point P is obtained from moving 3 units, 1.5 units to the right and minus 6 units down, and therefore the coordinates of P are nothing but minus, moving to the right is positive 1.5 and moving to the down is about moving 6 units, that is minus 6 out in the y coordinate. Therefore, I have my coordinates of P, which are 1.5 and minus 6, is how I understand the locating of this point with its x and y coordinates. Therefore, with the concept of locating the position of P with respect to its initial position, moving right and then down, or moving left and then down, etc., we can locate the coordinates. In this case being moving 1.5 units to the right, x coordinate is this and -6 is the y coordinate. Therefore, for this P, my abscissa is 1.5 and my ordinate is -6. Similarly, let's see the coordinates of Q. When I have the coordinates of Q, I clearly see that this is the point which moves -1.5 units left. Q moves 1.5 units to the left and then moves 1, 2, 3. So I have this be exactly between 4 and 6. So I assume this to be 5. So Q moves 5 units up. So Q moves -1.5 units, 1.5 units to the left and then 5 units up. Therefore, I have this to be my coordinates of P, Q, -1.5 and 5 is how I locate the coordinates of Q and P. P is 1.5, -6 and Q is -1.5, 5. Locating the point from its plotted point. Locating the coordinates of P using the reverse process of understanding the graph is what is the session. Next comes that we have discussed about Cartesian plane, locating a point, and the reverse process of understanding the finding of coordinates using the point located or plotted on the graph. Next comes in applying this into the real life situations. So let's take the opening problem which we have discussed about a ship in the sea and reaching the bank, reaching its destination. So when the ship would like to reach to the seashore, let's see how it can estimate through the use of coordinates. For example, I take the sea. Now here is the sea in which there are small islands. So here is one island and here is another island. And then here is 1. So this is island 1, this is island 2, island 3 is how we understand the concept. Now the ship which is out here would like to reach to the shore. So let's see where it reaches. Now the person in the ship would be puzzled to know which is the nearest island to which he can reach. So let's see this interesting problem connected with coordinate system. He can resolve the issue by just using the coordinate system or the Cartesian plane. So this person is wondering about moving to the nearest island. So how does he estimate moving to the nearest island for the seashore? So let's see how that can be done. A person estimates that this island is, say, the person in the ship estimates that the island 1 is two units to the right and 3 units to the top is how the person estimates the ship from the island 1. He also estimates that the island 2, which is just besides this on the other side of the ship, is estimated to be 3 units to the left and 4 units up. So this ship moving to island 2 must move 3 units left and 4 units up. And the third island is about the person moving to the island 3, where he is 5 units left and then he is 2 units down, is how he estimates each of I1, I2 and I3. I1 stands for island 1, I2 stands for island 2 and I3 for island 3. Now he is in this dilemma. He needs to solve this puzzle of reaching to the nearest island. So he is puzzled between island 1 and he is puzzled between island 2 and he is puzzled between island 3. Which island does he reach? Is the biggest question. He needs to search for a mathematical solution for this problem. Imagine that he is first reaching to the destination of island 1. So let's see how he can just do that. As I see this, I clearly see that let me take the scale of 1 centimeter as 2 units. And let me locate the first point which the ship can reach to island 1. Now for reaching island 1, the ship has to move 2 units right and 3 units up. So here is where the destination is of the ship. Towards island 1. This is island 1. And next, the next destination is about reaching island 2, where the ship moves. Here is the ship. Where the ship has to move 3 units left and 4 units up. So it has to move 3 units left and 4 units up. So here comes the island 2 into this place. And then the ship has to move from its initial position origin to reach island 3 for a distance of 5 units left and 2 units down. So 5 units left and 2 units down is about moving to this place I3. So I have my destination, which is island 3, island 2 and island 1. So once I reach to these 3 lands, I get that there are 3 positions which the ship makes. And the question comes on how we can just find the nearest distance that the ship moves to reach to the islands. So let's see what is the least distance made by the ship to reach to each of the islands. Now as we see here, this is clearly origin and this is I1, I2 and I3. Let me first locate the coordinates of I1. So let's see how we can locate each of the coordinates I1, I2 and I3 and then come to the actual puzzle of solving the nearest distance which the ship can reach to the island. Which island would be the nearest to the ship? Now let's see the distances of the ship from each of the islands I1, I2 and I3. Before that, we need to locate the coordinates of I1, I2 and I3. So here I identify that the coordinates of I1 are 2 and 3. And the coordinates of I2 are -3 and 4 because it moves -3 left and 4 units up. and the coordinates of I3 are minus 5 to the left and 2 units down, so it's minus 5, minus 2. Therefore, the coordinates of I1 are 2, 3. The coordinates of I2 here are minus 3 and 4, and the coordinates of I3 is minus 5, minus 2 is what we get for each of the coordinates. Now let's also take the initial position of the ship into account, where the initial position of the ship is denoted by O, which is origin. Now comes the question on which island is the nearest to the ship in the sea. So in order to find the nearest distance, it's all about finding the distance of O from I, the distance of O from I2, and the distance of O from I3. Now once we know the distances, we can find the least distance, which gives the least. So let's see how we can use the distance. So let's first initially find the distance of the ship from island 1, which is from O to I1, and that is the distance of ship from island I1. So clearly we know that the distance of the ship from island I1 is OI1, and this can be found by using the distance formula between O and I1. So distance of O from I1 is root of x2 minus x1 whole square plus y2 minus y1 whole square, the formula for distance between 2 points. So the distance of O from island I1 is root 13 units. Similarly, my next target is to find the distance of the ship from island I2. Here being the island I2, this is the distance which I need to find. So distance of ship from island I2 can be found as OI2, because this is origin and this is I2, so OI2 refers to the distance from island I2. Using the same formula for distance, root of x2 minus x1 whole square plus y2 minus y1 whole square, I get the distance from O to I2 using the coordinates of I2 minus 3, 4 and origin, which is 0, 0. Therefore, I have this to be minus 3 minus 0 whole square and 4 minus 0 whole square. And this, on further simplification, gives minus 3 whole square, which is 9, and 4 square, which is 16, which gives me root 25, and which is 5 units. So distance of ship from island I2 is 5 units. Similarly, the distance of ship from island I3. So how do we find the distance of ship from I3? It is the same repetitive process where the distance of O from I3 is OI3, and which is using the distance formula, and there I get the distance from O to I3, which is root of minus 5 minus 0 whole square plus minus 2 minus 0 whole square, which is root of 25 plus 4. 5 square, which is 25, and minus 2 whole square, which is 4. So 25 plus 4, which is root 29. So clearly I get this to be root 29 units. Therefore, by verifying through the 3 different distances, I find that distance of the ship from island I1 is root 13 units, distance of the ship from island I2 is 5 units, and distance of the ship from island I3 is root 29 units. So as I see clearly out here that root 29 is greater than root 25 greater than root 13, I clearly see that this root 29, which refers to island I3, root 25, which refers to island I2, and root 13, which refers to island I1, makes me clearly understand that island I3 is the farthest from the ship and island I2 is the next farthest from the ship, and the island I1 is the nearest from the ship, and therefore the person who is sailing in the sea in the ship would definitely reach to the target of reaching island 1 because it is the nearest and easy to reach for the safer side. Hence the person has resolved the process of reaching the destination of the puzzle of 3 islands by using the concept of coordinate geometry. In this case, I am in the ship, I reach island 1 because it is the nearest of all the 3 islands. This is how I understand the applications of coordinate geometry and Cartesian plane in real life, resolving the issues through real life situations. Now that we have discussed about the coordinates and the x coordinate being called the abscissa and the y coordinate being called the ordinate, we have a specific terminology even for the point we refer on the Cartesian plane. Let's see how we can represent or use the terminology, the correct terminology for a coordinate in a Cartesian plane. As we have seen through the coordinates, here comes the importance of identifying the definition of ordered pair. As we all know that a pair is combination of 2 different objects taken together. Here the pair refers to x value and y value taken as a pair. So an ordered pair refers to the x and y coordinates or the abscissa and the ordinate taken in the bracket paired together. That is, when I take a point 2, 3, it indicates that for x equal to 2 is being paired with y equal to 3, and they are associated with each other. Every pair have a certain relation, and here the relation is that these 2 coordinates pair to form a point. So these 2 coordinates x and y are paired to form a point in the Cartesian plane. So here I have the Cartesian plane in which 1, 2, 3, 4. I clearly see my x coordinate, which is 2, and y coordinate, which is 3, are paired together to form a point 2, 3. The pair forms a point in the Cartesian plane. Is how we understand the pair. But what is an ordered pair? It is very important that when you take the coordinates x and y taken in the pair, reversed order will never be equal. an important note to be made in the branch of mathematics. The pair xy will never be equal to the pair yx because they maintain an order, and hence every point xy in the xy coordinate system or the Cartesian plane is called an ordered pair. The first value refers to the x coordinate and the second value refers to the y coordinate. Abscissa and ordinate are ordered, and xy cannot be equal to yx for all x and y belonging to R is how I understand the properties of ordered pairs. The pair must be ordered. For example, 2, 3 point cannot be equal to 3, 2, which can clearly be verified because 2, 3 is here, and when I take 3, 2, I move 3 units right and 2 units down, and then I get this point to be Q. Therefore, my 3, 2 and 2, 3 are not exactly plotted at the same point. They are different from each other, which clearly proves that 2, 3 is not equal to 3, 2. Therefore, xy is not equal to yx. The 2 points are equal only when they are in order. Xy must be equal to xy, but xy cannot be equal to yx, is how I understand the definition of an ordered pair. An ordered pair and its properties. Let's see some properties connected with coordinates in the Cartesian plane. As we have discussed about the ordered pair in which x, y in a Cartesian plane can only be xy, but xy cannot be equal to yx. Say, for example, let me take the properties. If I take the ordered pair x, y as a point and I say this is equal to the Cartesian ordered pair when it's reversed, then in that case this is possible only when x equal to y, is how we understand the property. This property can never be true if they are not equal. They have to be equal. If the abscissa and the ordinate are equal, only then I get the reversing property holding true. For example, let's take an example problem. If I have the property 3, minus 2, clearly when I reverse, we know that this when reversed gives me minus 2, 3. So the reversing of the point 3 minus 2 to minus 3 clearly makes me understand that 3 minus 2 is not equal to minus 2, 3. But if I take, say for example, another set of example which says 5, 5. I have the coordinate 5, 5 which I would like to reverse. So when I reverse the x and y coordinate, I get here again 5, 5. Therefore, in this case, my coordinate in which the coordinates are reversed are both equal. Therefore, in order that xy must be equal to yx, I should have the condition that this x and this y must be same. Xy equal to yx only when x is equal to y. If x is not equal to y, xy is not equal to yx, is how we understand the properties connecting the Cartesian plane. Now that we have discussed about the coordinate geometry, now comes on how we can represent the axis in different forms in real life. As we have discussed about x and y axis, x axis being the horizontal axis and y axis being the vertical axis, what would be its significance in real life? Let's see an example problem to understand this concept more better. For example, I have axis representation in real life, x-axis and y-axis representation in real life. For example, I have a table of time and distance, where T stands for time and D stands for distance, time in seconds and distance in meters, is how we try to connect. Say for example, I take a real life problem of a 100-meter sprint race where the Olympic participants tried to run in 100 meters. Usain Bolt is what I'm talking about. So here, let's try to take the time and distance problem in understanding the axis representation in real life. For example, say in the first 2 seconds, the distance run by the Olympic sprinters in average is 30 meters, 20 meters, and then say the distance run in 4 seconds by the sprinters is 39 meters, and say in the distance run in 7 seconds is 71 meters, and the distance run in 8th second and the distance run in 10th second is say 100 meters. So approximately I would like to say that this is the table of all the time and distance. The first row refers to the time taken by the sprint participant in each of the seconds, and the second row represents his running distance of 100-meter race. So this gives me a picture of a real life problem, which I'm going to convert into axis representation. Quite interesting. So here the time refers to the first 2 seconds. The distance covered by the sprinter is 20 meters. Distance in meters, time in seconds. So the first 2 seconds, the distance covered by the sprinter is 20 meters. And for the first 4 seconds, the distance would be 39 meters as recorded, approximately. When the time taken is 7 seconds, it is assumed that the distance traveled by the sprinter is 71 seconds. For the 8th second, it is said to be 89 meters. And then coming to the 9th second, it is 94, and 10th second, it is 100. Is how I understand this in real life situation. How do you convert this into axis is the biggest question out here. In order to convert this into axis, we try to take always this is called t-axis because x-axis is now represented by the variable t. Your x is now the time in seconds and your y is now the distance in meters. So I have here the time which I'm going to denote with 2, 4, 6, 8, 10, 12, Now the scale. What am I going to do with the scale? As we have discussed that every graph has 1 centimeter grid distance, we just represent the 1 centimeter grid distance with different values as scale. So here, because my values are up to 100, taking each of the grid with 1 centimeter equal to 1 unit on y-axis becomes a tough challenge. Therefore, I increase the scale on y-axis. So each of the 1 centimeter grid is taken to be 25, 50, 75, 100, 125. So here I adjust the scale on x-axis, which is my t-axis, to be 1 centimeter equal to 2 units, and then on this d-axis, which refers to the y-axis, the distance axis is 1 centimeter equals 25 units. This makes me clearly understand that the scale is a significant tool in making the window setup, so that I can understand how the different values can be adjusted through the scale. A scale is an important tool in adjusting the values into the graph. So here I have my t-axis, which refers to the time, and my d-axis, which refers to the distance of the sprinter in 100-meter race. So my time is in seconds and my distance in meters for the 100-meter sprint race. So let's see how I can plot the points. I can have my t is 2, my distance is 20, approximately here. My t is 4, my distance is 39, approximately somewhere here. My t is 7, my distance is 71, so I have this to be approximately here. That's how I get. When I have 8 seconds reached, my distance would cover 8 and 9. I have this covered, and then 8 seconds is 89, which comes, and 9 seconds is 94, and 10 seconds is 100. Is how I make the distance time graph. This graph is called distance time or time distance graph, where this refers to t-axis and this refers to d-axis. So any problem in xy coordinate system can be applied in real life situation. For example, this being the time and distance of a 100-meter sprint participant in the Olympic Games. The chart of Usain Bolt.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.